Hello and welcome to the Math League Media YouTube channel. Today we're going to be going over Team 7 from our 12504 release, which was one of our high school releases for this year. Problem number 7 reads, call a sequence of not necessarily distinct integers, all between 0 and 5 inclusive, 5 clean, if no two consecutive elements in the sequence have a sum divisible by 5. For instance, 120 and 40,251,344 are 5 clean, but 105 is not. Compute the number of sequences that of length 4 that are 5 clean. Now notice that for any pair of two distinct integers between 0 and 5 inclusive, each integer will have exactly one matching pair that will add up to a multiple of 5. That'll be 0 and 5, 1 and 4, and 2 and 3. Additionally, notice that 0 plus 0 is 0, which is divisible by 5, as is 5 plus 5. So we also can't have two instances of 0 next to one another, and we can't have two instances of 5 next to one another either. So this tells us that when we have a 0 or a 5 present in our sequence, we have to be a little bit more restrictive about what goes next to those objects. Additionally, notice that in a sequence of length 4, that there will be 2 digits on the interior of the sequence with 2 neighbors, and 2 digits on the exterior of the sequence with 1 neighbor. So we have slightly more restrictions on what can go in these 2 middle spaces than we do in those 2 larger spaces. So it makes sense to split our cases into whether 0 or 5 are in this in the interior of this sequence, or if they're not. Now, if they're not, then we have 4 choices for the second digit in the sequence, and no matter what we choose, there will be exactly one number restricted from being the other number in that sequence, so we'll have 3 choices for the other, for 12 choices for the interior. And then, no matter what integer between 1 and 4 inclusive is in this space, then whatever goes in this space simply has to not be its matching pair. So there's 5 choices for what goes in this space. And similarly, we have all but the choice that will make this number, which isn't 0 or 5, add up to this number, which isn't 0 or 5. And that also gives us 5 choices in this case. So 12 times 5 times 5, or 12 times 25, which comes out to 300. Now let's say we do have a 0 or a 5 in one of the middle 2 spaces. Well, if there's a 0 or a 5 in one of the middle 2 spaces, then we can't have a 0 or 5 in the other of the middle 2 spaces because they cancel each other out and they make the sequence not 5 clean. So we have to pick exactly one of these 2 spaces to have a 0 or a 5 in the interior. And then once we've picked one of those 2 spaces, we have a choice of either putting 0 or 5 in that space. And then finally, once we've picked whether we're putting a 0 or a 5 in one of these spaces, let's say, for example, that we pick to put a 0 in this space, then we can't put a 0 or a 5 here, but we can put any of the numbers from 1 through 4 inclusive, or any of the integers from 1 through 4 inclusive, for 4 choices for the other number in the interior. Then for whatever number that goes here, we'll have 5 choices, any number except the one that makes this number add up to a multiple of 5, for the exterior digit on this side, and on the side with the 5 or a 0, we can't have 5 or 0 being that exterior digit either, so we have 4 choices for that side. And our total number of cases in this case is 2 times 2 times 4 times 4 times 5. 2 times 2, is 4, and 4 times 4 is 16. 16 times 20 is the same as 320 times 10, or 320. Or 32 times 10, or 320. And then adding these 2 cases together, we're given 300 plus 320, or 620 possibilities, which is our answer.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.